I'd like to give you a real quick selective answer video. I'm going to go over number 2. That's a subtraction problem. So subtraction means fraction. You want to divide 8 and 4, but that actually gives you the log of 2. Now with number 4, we have an addition problem, but we also have a coefficient. So you always want to bring coefficients up as exponents first. That way you'll be able to condense this together using the addition sign correctly as multiplication. Now when you do multiplication, you're going to end up writing this as 1 log of the x and that x squared. But look, you can actually simplify x times x squared. You can write that as x to the third, or as x cubed. Now with number 5, we have multiple addition and subtraction signs. Let's kind of keep straight here. Whatever's being added is going to end up in the numerator. Whatever's being subtracted is going to end up in the denominator. And you're only going to have 1 log. So force yourself to write 1 log and get this fraction ready. Ready for a 3 that goes in the numerator, ready for a 2 that goes in the numerator, and then ready for a, now did you see this 4? This 4 is going to have to come up as an exponent, so we're going to get 2 to the 4th in the denominator. And so when we do a little bit of simplifying here, I feel like we're going to end up with a 6 over 16, which when we simplify, which we should, can end up being 3 over 8. So we have the log of 3/8. That problem is a little trickier. Let me just highlight one more time that you have to bring that 4 up as an exponent. So we end up with 2 to the 4th power. That's going to give you 16. Now, number 8, you have to recognize kind of backwards that number 8 has 3 units. And we're talking about a 5, an x, and a 7. So what that means is we're going to end up with 3 logs. Did you write the log 3 times? So if I write this out 3 times, then it's going to allow me to put the 5 up here, with the log that's being added. It's going to allow me to put the x, and then it's going to always have the denominator be the one that's subtracted. So I'm going to put the log of 5 plus the log of x minus the log of 7. And oh, by the way, the log base 5 of 5 is actually equal to 1. If you wanted to, you could have changed that to the number 1, which is nifty, but I'll say it's not required. As long as you split this thing up into 3 parts, that's the best. And then we do some widths and properties, do a little bit of combining. I'll tell you that for a problem like this, I don't want to mess with 32 to the 3rd power. That's going to be a huge number. So instead, what I'd like to do is bring this 3 down as a coefficient. And again, the reason I'm doing that is because I don't want to mess with having a big number. Now, I can mess with thinking about 2 to what power is 32. 2 to what power is 32 is the number 5. And so really that log is equal to 5. So that means this is going to be 3 times 5, which we know, of course, is 15. And then I'm going to go over the last one with you, because definitely when you have subtraction, you want to think fraction. And I like fractions because they actually make numbers get smaller. And so I can put the 27 in the top, I can put the 3 in the bottom, and again, I'm actually able to divide these numbers to be the number 9, that is the log of 9. And wait a minute, 3 to what power equals 9? 3 to the 2nd power equals 9. So you can actually evaluate that log to come out to be the number 2. Now, just saying, you could have done this problem another way. I don't want to overwhelm you, but maybe you're saying, Miss Naylor, I actually just figured out each of these on their own. Like the log base 3 of 27 is the number 3, and the log base 3 of 3 is the number 1. So, we're just subtracting 3 minus 1, and that also equals 2.